working through these examples. So again, you should know at least one side and then two more measurements. So they can be in the forms of angle or sides as long as you have one side. So I will just repeat myself. If they give you all three angles, but no measurement of the side, you cannot find the sides of those triangles. Then you won't be able to solve that triangle. So these actually break down into four different cases. You can have two angles and one side. So those would be the cases of AAS. So you have two angles and a side, or, depending on, is the side going to fall between the two angles? So that can be ASA. You can have two sides and an angle opposite to them. So that is your case of SSA. These are the two cases we are going to be talking about in this section using this idea of law of sines. Now, if they give you three sides of your triangle, and then, of course, we're trying to find the missing angles, or if they give you two sides and the angle that is included between them, SAS, this is actually going to fall into our next section, which is the law of cosine. So we have to use law of sines in the first two cases, and we have to use law of cosines in the second two cases. So that's what we're going to be discussing in section 3.2. So let's look at here with our law of sines. You've got your ABC as your triangle with the sides, small letters ABC. So this is the relationship or the law of sines over here. Side A over sine of angle A is equal to side B over sine of angle B is equal to side C over sine of angle C. So you will see in this formula or rule, you're using the sine on the angles A, B, and C. So that's why this is called law of sines. You can obviously take a reciprocal of those fractions and that will convert into this format. But this is also, just the same thing. This is also your law of sines. We're just, inverting our fractions over here. And again, they're talking about if you want to see the proof, you can look at page 308 of your textbook if you wanted to see why this works. So let's talk about the different types of triangles we may have and how we can go about solving them. So we'll keep our law of sines handy over here so we can use that.
So I have a quick question.
Yeah, go ahead, Scotty.
I know I asked you on the homework, I just haven't looked at it yet. Are you able to go from A over sine of A equals C over sine of C, or do you have to go from A over sine of A equals B and then?
So no, it depends on what information is available, but yeah, you can completely skip the B part and you can just set this equal to as sine of A equals sine of C, that left-hand side fraction equal to the right. Or you can, if you don't want to use angle A because that's not the information given to us, you can set B equal to C, A equal to C. So yeah, different combinations work, not a problem at all. And you will actually, oh, okay. Not sure why it logged me out. There we go. Okay, so the first example we're looking at is going to be, one of those first cases for law of sines over here. So we're looking at number 10. So with this example, you will see the capital letters, again, remember, are for the angles and the small letter is for the side. And of course, you can see how they're giving us the degree measurement. So we know those guys are angles also. But, just in case they were going to be working in radians or something, you wouldn't have the degree symbol. So just remember, capital letters are for the angles. Small letter is for the sides. So let's take a look at, what we're looking for this guy. So let's move it over here. This is number 10. Okay, so capital A is 24.3 degrees. Capital C is 54.6 degrees. And then side C, and I'm actually going to write it in like this cursive format so you will be able to tell the difference between capital and small c. And this guy is going to be 2.68. Now, if you look at the instructions for this, basically they're telling you use the law of sines to solve the triangle. And then the rounding is for 2 decimal places. So solve the triangle means find the missing angles and find the missing sides, basically. So looking at this guy over here, if we just did a general triangle just to give us an idea, and you will see how both my angles A and C are acute angles. So angle B, and this is just a generic form. Angle B, will it be an acute angle or an obtuse angle? Because, will it be greater than 90 degrees or less than 90 degrees? So if these are your angles A, B, and C, the opposite sides are going to be sides A, B, and C. So again, angle A is 24.3 degrees. Angle C is 54.6 degrees. And then side C is your 2.68. So how do you think we can find angle B over here, guys? What will we need to do to find angle B?
Add up the angles already found and subtract 180.
Yeah, very nice. So remember all 3 angles. Doesn't matter if you have a right triangle, an obtuse triangle, all your 3 angles are going to add up to 180 degrees. So basically you are going to be taking 180 degrees and subtracting the known angles from it. So 24.3 and then minus the 54.6. So what will your angle B come out to be? Okay, Lowell, you've got 101.1. Let's see, Katie, you have the same thing. Oh, Eusebia, I just saw your question. That's fine. If you have to leave early, that would be okay. And then your grades have already been put in, but obviously, if you get a better grade, if you retake an exam, I will replace it with the higher grade. So don't worry about that. So I've got 101.1 from Lowell, Katie, and Alicia. Very nice. So as you can see, since this is actually a angle larger than 90 degrees, of course, my triangle is not of the right form because it should be an obtuse angle instead of an acute angle, but that's all right. Don't worry about it. So we've got our 3 angles now. Now we need to find sides A and B. So this is where your law of sines and cosines is going to come into play. So let's start by finding side A. So remember, using your law of sines, you can do this between angles A and B. You can do this between angles A and C. Honestly, it doesn't matter. You can try it 2 different ways if you want. So we will do side A over sine of A equals. We don't want to do B simply because we don't know what side B is. So obviously, if you set this up as B over, sine B, well, that doesn't help us much because we don't know what side B is. So instead of that, obviously, you want to use C and sine of angle C. So side A is the only unknown side. You've got sine of angle A, which is 24.3 degrees. We know side C is 2.68. And then sine of angle C will be 54.6 degrees. Now, just like we solve any equation, you will be solving this in the same way. So we need to isolate side A because that's what we're trying to find, which means we will go ahead and multiply both sides of our equation by sine of 24.3 degrees. So that way it will end up canceling out from the left-hand side and you're just left with side A. And you will notice how I use the first version of our law of sines, because since side A was the unknown side, that's why I put it on the top. Let's say if we were trying to find angle A, then I would have used the reciprocal version of our law of sines over here. So just make sure your calculator is in the correct mode. And then you can go ahead and type that right-hand side into your calculator and try and solve that. So let me know, what do you get as the measurement for your side A for this triangle? Okay, and Abdul Aziz, you're rounding it to 2 decimal places. Okay, let's see, I've got 1.353 from Abdul Aziz. Lowell, you've got 1.35, Eusebia 1.35, and Shu 1.35. Billy, same thing, Ozzy 1.35. All right, perfect, guys. So the raw answer is coming out to be 1.3529, and it keeps going. So rounding it to 2 decimal places will be 1.35. Now, remember, we always talk about rounding errors. We are always trying to avoid rounding errors. So since you will see side A is a rounded answer, right? Because the regular answer is much different than a rounded answer. So when you are finding side B, instead of using, angle A and the side A, use side C. So basically, when you're rewriting for the side B, we can use B over sine B, and then I will actually go back and use C and sine of C. So that way I don't get a rounding error by using side A. So B is unknown. We just found angle B, which came out to be 101.1 degrees. Our side C is 2.68. And of course, our angle C was 54.6. So same obvious calculation. This time we will end up multiplying both sides by sine of 101.1 degrees. And then again, if you can tell me what the side B calculation will come out to be. Hey, Billy, you've got 3.23. Can anyone else confirm that answer for me, please? Abdul Aziz, okay. Katie, very nice. So again, your raw answer is coming out to be 3 point low. Okay, very good. 3.2263, and again, it keeps going. But rounding it to 2 decimal places would be 3.23. Alrighty, perfect. Good job, guys. So again, very simple, very straightforward. But now we have our 2 missing sides. And then, of course, we had our missing angle. Did you guys have any questions on this example here? Okay, so remember, this is for triangles that don't have a 90-degree angle with them. So this was number 10. For our next example, I actually thought we could use an application problem instead of just a generic problem like this one. So that's why I've picked number 45 over here. So this one actually is the scenario where you've got two angles and the side that falls in between them. So if you look at the example we just did, we had our two angles, A and C, but the side C was not, the side that falls in between the two angles. That would have been side B. So this next example that you have over here, you will see this known side is actually in between our two angles. So just a different scenario for the same type of example. So this one is saying a tree grows at an angle of 4 degrees from the vertical. So, you can see that instead of being exactly at a 90-degree angle with the ground, the tree is making a 94-degree angle with the ground. So that's, your 4% plus 90 degrees is how they're coming up with, that 94 angle. And they're saying it's because of the winds that, the tree has, kind of been moved a little bit on the other side, making up that angle. So they are saying at a point 40 meters from the base of the tree, the angle of elevation to the top of the tree is 30 degrees. So you can see, going from the base of the tree, 40 meters to the right, from that point, we are making a 30-degree angle of elevation to the top of the tree. So same thing, we're still trying to solve this triangle, which means we are trying to find this missing angle, and then we're trying to find, the three sides. So you've got your height of the tree, which is the H, the X side, and then of course the top angle. So let's start with that one. We'll go ahead and write all of this information down. Okay, so you've got 40 meters, a little bit of a angle over here, and our triangle here. So this is making 94 degrees. This guy here is 30 degrees. We've got 40 meters over here. And then we want to know what is the height of the tree, what is this side, and of course the missing angle. So just to kind of keep it in line with the other examples, I'm going to call this C, I guess A over here and B over here. So this would be side C. This would become side A. This could be side B. So let's start by talking about angle B over here. What is that guy going to come out to? Abdulaziz 56. Yeah, same thing, right? All three angles have to add up to 180 degrees. So same thing, you will take 180 degrees and just subtract the two angles from that. Alrighty, so this guy will be 56 degrees. Now, let's find the height of our tree next. Why not? Which is actually the main question that I believe they want us to find. But you will see in part A, they're talking about find an equation that you can use to find the height H of the tree. So they want us to start with the equation and then actually find the height. But we are also going to find the other missing side, just so you're comfortable with the calculations. But how do you think we can come up with the equation to find the height? what law of sine would you use to help you out with the given information that you have?
A over sine of A equals B over sine of B.
Okay, so you are using side A, which is our height, which is what we're trying to find, which would then have to be above sine. Oh, what's going on? And then did you say B, Scotty? Because that's the 40 meters side, right? That we know. So
Yeah,
that would be side B, and then we found angle B, so of course
And-
that will come in handy. Go ahead, Scotty.
and then you're gonna move your sine of A over to the other side.
Very nice. Yeah, so that we can isolate the side A. Very good. So move the sine of A to the other side. This will cancel out. So now if we have to, translate this into the known values, this can be our height, which is also side A. Side B is 40 meters, so this will be 40 over sine of B. Angle B was 56. So this will be sine of 56 degrees, and then you're multiplying this with sine of A, which was the 30-degree angle. So that's the equation. And then for the part B, to find the height. And they didn't tell us about rounding. So for now, let's just keep it at 2 decimal places like the previous example. So what do you think this height will come out to be?
Comes out to 24.12.
24.12, okay. And again, guys, obviously, hopefully your calculator will stay in degree mode from the previous examples, but just make sure, you're keeping your calculators in the correct mode. Did anybody else get that answer for the height of the tree? Scotty said 24.12, I believe. Lowell, okay. Billy, same thing. Shu, all right, very nice. So again, guys, our raw answer is 24.1243, and it keeps going, but keeping it at 2 decimal places. And since they used meters for the, the base distance, this will also be in meters. So same measurement, unit of measurement over here. So that's the height of the tree. Now, if you had to find that missing side C, what would you use? What would your equation end up looking like for this side C?
C equals B. No, C equals B over sine of B times sine of C.
Very good. Yeah. So again, just using the known side that we knew, which was side B or 40 meters, using the angle for that, and then sine C. Alrighty, perfect. So this guy would then come out to be 40 over sine of 56 degrees, and then of course you're just multiplying this with sine of 94 degrees in this case. So what will that distance come out to be? Okay, let's see, Scotty, you've got 48.13. Alicia, same thing. Abdulaziz, already. So again, your raw answer is 48.1311, and it keeps going. But 2 decimal places would be 13, and again, this would be in meters. Now, as far as this problem goes, they're not going to ask you to find side C. They're just going to ask you to find the height of the tree. But, this is just to show you, if you were looking at one of these generic examples, then, of course, they would want you to find all 3 sides and all 3 angles. So just to kind of help you out with that. But as far as this question goes, they were only interested in the height of the tree. Any questions on that, guys? So, a lot of times we use the same idea to find, height for buildings and stuff like that. And a lot of times they'll use the shadow length of the structure. So, if it's a tree, if it's a building or whatever, they'll measure the shadow because that shadow is going to be, on the ground level. So you can measure that. And then you can use the angle of elevation from the tip of the shadow to the, top of the structure. Find the angle of elevation, and then you can calculate the height of, whatever you are trying to find the height of, a building, a tree. We actually use this idea of law of sines also to estimate the height of, something like a mountain. So you can see here in this example, they're telling us that in the 1850s, the surveyors used law of sines to calculate the height of Mount Everest. And they were within 30 feet of what is the currently accepted value. So just imagine how close they were, because, when you're talking about hundreds of thousands of feet, because Mount Everest is, oh God, I don't even remember now, of something large number. In that case, when you're talking about being within 30 feet of the height that is accepted, that's pretty remarkable. So this is kind of the, idea we would use for, finding the height of a mountain and stuff like that. So that is the first case where you are given two angles and one side. But then, what happens if you are trying to find something where you are given two sides and one angle? So that's actually our second case over here. So this is what we've talked about. This is what we're getting ready to look at. But what happens with this guy, as you will see, this kind of gets into a little bit of an ambiguity. So we're talking about an ambiguous case over here. So when you are given two sides and one angle, there's actually three different things that can happen. You can not have a triangle which exists, which would not satisfy those given conditions. You will get one exact angle which will satisfy the conditions, or you can actually also come up with two different types of triangles which would still satisfy those conditions. So when you look at this ambiguous case, this little box over here really comes in handy. So we are defining, which is that height the triangle forms with the base of the triangle. So, remember the height is always going to be perpendicular to the base of your triangle. So they're defining that height as b times sine of A. And in this case, they are saying, if you are looking at A being an acute angle, so smaller than 90 degrees, and the side A is going to be a height smaller, the side A is going to be a length smaller than the height, then that is where you have no triangle. So you do not get a triangle which will satisfy that condition. The other place where you get no triangle at all is when A is an obtuse angle, so larger than 90 degrees. But in that case, your A value is smaller, or even if it is equal to the B value. So if the sides A and B are going to be, equal in length, or side A is less than B, there is no triangle in that case either. Now for your acute angles, where your angle is less than 90 degrees, if your A is equal to the H value, so you can see it's going to be basically a 90-degree triangle. This is where you will be able to get one exact triangle which will satisfy the conditions. Or if A value is going to be equal to or greater than B, in that case, you would again find one single triangle. For an obtuse angle, if A is obtuse, your A side has to be greater than the B side, and then you find one triangle. The only time where you will get two different triangles possibly is A would have to be an acute angle, and then side A has to be greater than H, and B has to be greater than A. So side H would be the smallest side, then greater than that would be side A, greater than that would be side B, and that's when we actually come up with two different triangles. And you can see in the illustration, we've got one triangle, which is this one over here, and we've got another triangle which actually goes all the way to this side. So that would be your second triangle. So it just kind of depends, with what the case ends up looking like. So let's take a look at our first example over here with this ambiguous case. And for this guy, let's look at number 24. Okay, so let's get back to the page over here. Alrighty, so you can see in this one, our instructions are use law of sines to solve, if possible, the triangle. Okay, no problem. To find, if possible, the triangle. They're saying if two solutions exist, find both of them. And again, we're rounding our answers to 2 decimal places. So we're looking at number 24 over here. Angle A is 110 degrees, and then we're given sides A and B. So let's take a look at what this guy will look like. So you can see angle A is 110 degrees. So obviously that's an obtuse angle to begin with. And if that angle is the obtuse angle, then obviously your other two angles have to be acute angles, because otherwise they would not add up to 180 degrees for all three angles. So let's take a look at this guy over here. So if you look at the conditions that we have in our little box over here, angle A is an obtuse angle. So if it is an obtuse angle, we're looking at these last two cases over here. And so we need to know, what's the relationship between sides A and B. So you can see side A is smaller than side B, right? Because this guy's only 125, B is 200. So when side A is smaller than side B, remember there's no triangle which will satisfy that. So let me just kind of show you what's happening here. So we'll just do a rough sketch. If this is angle A at 110 degrees, and we know these two angles are going to add up to 70 degrees, so they're going to be pretty small. If this is angle A, then this is going to be side A. Let's say if this is angle B, this would be side B. So if A is going to be your largest angle, side A has to be your largest side. Because again, if you remember this from geometry, the largest side is opposite the largest angle. So if 110 is our largest angle, but then in our measurements, they're telling us side B is the larger side. A is 125, B is 200. Well, that is not possible because the side across from side angle A has to be the largest side, and that's not the case in this example. So that's why there is no triangle which will satisfy these conditions. So in this case, angle A is obtuse and A is smaller than B. So that's why we have no triangle. So again, I will say it one more time, guys, just keep this little, chart handy with you so you can kind of use this to help you out with the different cases. All right, so that was number 24. Now let's look at 26 and see what kind of example this guy might have. So number 26. Yeah, Eusebia, we will be actually looking at those kind of examples with the degrees, minutes type of angles also. I think I actually have one in one of my next examples. So let's take a look at 26 over here. And this one, you will now see we are given A is 76 degrees. So that is an acute angle, right? Smaller than 90 degrees. And then sides A and B are also given to us. So let's take a look at how this will change when you have an acute angle. So let's go ahead and write this guy down. Okay, so for number 26, angle A is 76 degrees. Side A is 34. And you will see side A, 34, is greater than side B of 21. So let's see how this will help out. Okay, so we have an acute angle, and we have side A greater than side B. So you are actually looking at this third case over here, because we have an acute angle and then side A is greater than side B. All right, so let's take a look at how we can solve this guy. Okay, so side A is 76 degrees plus this would be 34. Side B would be this guy here, 21. And then side C. So now we should be able to solve this triangle. So in this case, you will see, since we're only given one angle and two sides, we will have to use one of the modified versions of our law of sine. So we have two sides and one one angle. So let's use that. So sine of A, I'm going to put that on the top and side A on the bottom. And then since I have side B, I'm going to try and find angle B. So this is the relationship we're going to go with. So we have sine of 76 degrees over side A, which is 34. We don't know angle B, so this is the unknown that we're trying to find. And then our side B is 21. So just like we did, in the previous examples, get that sine B by itself. So we can go ahead and multiply both sides of our equation by 21. So what will the sine of B value come out to be?
0.6.
Okay, so you are doing sine of 76. Again, obviously, we're still in degree mode. Divided by 34 and then multiply by 21. Do not round this answer, because remember, this is not our final answer. So you're getting 0.5993, and then let's see, 0.0302. This is the sine of B value. So how are we going to find angle B in this case, guys? What will we need to do to find that angle B? Very nice. Remember, when you're trying to find the angle, this is where we bring in those inverse functions. So you will actually end up doing arc sine or sine inverse on this number that we just came up with. That's why we're not rounding this answer. So use sine inverse on this number to help you find, angle B. And this one, we are going to round to do that 2 decimal places. So what do you think this guy will come out to be? Excuse me. Ozzy, you've got 36.820. So yeah, you're only doing it to 2 decimal places. So very good. We don't need that 0 at the end. So 36. And your raw answer is 0.81980. And it keeps going. But round it to 2 decimal places, this will become 36.82. Alrighty, so that's our angle B. So we have now found angle B. We need to find angle C and side C. So since we again used rounded number to come up with angle B, to find side C and angle C, I would again skip B and stick with A. So in this case, again, you can do sine of A over A equals sine of C over C. But before we do that, can you tell me what our angle C is going to be? Because now that you have both your angles, we should be able to calculate angle C. So what do you have for angle C? Abdulaziz 73.18. So we are doing 180 degrees minus angle A, which was 76 degrees, minus angle B, which is what we just found, and this should actually have a degree on it, 36.82 degrees. And 73.18. Abdulaziz, are you sure? Because that's not what I got. Does anybody else have an answer on angle C?
I do, but I also used a different rounded number.
Oh, okay. So I'm seeing Shu, Katie, Hero. Very nice. All righty. So yeah, when you subtract these, because we are keeping that 2 decimal place for angle B, so that will actually influence the answer for angle C also, which will come out to be 67.18. So just be careful about your calculation there, Abdulaziz. All right, now to find side C. So same relationship, but between A and C. So again, sine of 76 degrees over what was my A, 34. We now have, well, honestly, this would work, but it will be easier if we invert and do the reciprocal. Since we're trying to find sine C, it will be easier to put the C on the top. So side C over sine of angle C equals side A over sine of angle A. Yeah, this guy will be better. So we're trying to find C. This will be sine of 67.18 degrees. And then A was 34 and angle A is 76. So let me know once you have your answer for side C rounded to 2 decimal places. Alrighty, Billy, very nice. So you've got 32.30. So the raw answer is coming out to be 32.2981. And again, it keeps going, but when you round it to 2 decimal places, the 8 makes the 9 go up, and eventually the 9 makes the 2 go up. So this will come out to be 32.30, and this is for our side C. Okay, so this was an example of just having one exact triangle, which would satisfy our conditions over here. So you've looked at the 2 cases now, no triangle or one triangle. So for this next example, I actually had it for, those 2 cases where you can come up with 2 different answers. So let's look at number 32 over here. And this one you can see Eusebia is the one with the minutes as part of it. So number 32, again, we have angle A. It is still an acute angle because it is still smaller than 90 degrees. And then you can see our side A is smaller than our side B. So let's take a look at what happens with this guy. Okay, so angle A is 25 degrees 4 minutes. Side A is 9.5. Side B is 22. Okay, so let's go back to our So you will see how side A is less than side B. We of course have an acute angle. So we are looking at this case with the two triangles. And if you wanted to calculate the H, you can use this formula, right at the top, H equals B times sine of A. You can calculate that to make sure that your H value is going to be smaller than A also. But yeah, just looking at the fact that A is smaller than B, we have an acute angle. We are looking at the second, the case with the two triangles. So let's take a look at this guy over here. Now, in this case, you have two different options. You can either go ahead and convert that 25 degrees and 4 minutes into a decimal if you want to, or if you want to just use your calculators, degree, minute, and second calculations, you can do that also. Does anybody remember how you convert minutes into degrees? And I know this was back in chapter 1, but does anybody remember that?
Multiply by 6.
6, Scotty?
60.
60, yeah, thank you. Yeah, because remember there's 60 minutes to an hour, so that's kind of the calculation we go with. So if you're converting minutes into degrees, you divide by 60. If you're converting seconds into degrees, you divide by 3600, because that's 60 times 60. So those would be your calculations. So, whichever mode you are comfortable with. So guys, here you can see, since we have angle A, side A, and side B, we can actually start by finding angle B again, because we have every other information that we need. So you can again do sine of B over
Wouldn't you want to convert A first?
Do you guys want to convert A into degrees? Because if you want to do that, you will need to do 25 degrees plus 4 over 60 and convert that into degrees. I'm actually going to leave it with 25 degrees and 4 minutes. If you will look at your calculator, and depends on what calculator you have, you may either see the DMS key, or you may see degrees, minutes, and seconds on your key. So I'm actually going to be using this, since we are going to use the calculator to solve these anyhow. You can do that. If you wanted to convert this, the only difference is going to be, this is going to be a non-terminating decimal, 4 out of 60, because you're going to get 0.0 and then 66666 repeating. So, it can lead to rounding errors, and that's really the reason why I'm not very comfortable converting this guy into decimals. But, if you had a nice, that decimal that, would stop after 2 or 3 decimal places, that would be an easy one to work with. But since this guy is a non-terminating decimal, I honestly just want to leave it as minutes and degrees and minutes. So you are finding sine of B. Our side B is 22. This would be sine of 25 degrees and 4 minutes over side A, which is 9.5. And then, of course, to isolate that sine of B, you would multiply both sides by 22. So what's going to happen here, when you plug this into your calculator, and I'm going to try and see if I can show this to you maybe with Desmos, so you can see how you want to type this in. So we'll do our scientific calculator here, and trying to see if they have Okay, I'm actually not seeing.
In Desmos, you can't do minutes or seconds.
You cannot?
No, you cannot.
Okay, so for this guy, then let's see. We want to do sine of 25 degrees. That kind of is interesting because if we did plus 4/60 for those minutes, this is what you're going to get for the, and you will see I'm leaving that as a fraction, 4/60, because I don't want to mess around with those non-terminating decimals. So you can do that. And then we're dividing this by 9.5 and then multiply by 22. So this will be your answer for the sine of B, when you simplify that right-hand side. So this could be a workaround to, if you are using an online calculator that does not have degrees and seconds on it. But like I said, with your handheld calculators, if you have those degrees and seconds, then it definitely makes your calculation a lot easier.
You wanted your calculator in degrees or radian?
In this case, it will be degrees because you do have the 25 degrees and 4 minutes, so that is in degree mode.
I came up with a different answer.
What did you have?
I might have messed something up. Let me look.
Okay, so make sure we're in degree mode.
Mr. Ruka,
Did I change my mode? I did change my mode, sorry.
the problem you're working on, it's the same as mine except for the degrees and seconds are different, but it's telling us to find case 1 and case 2.
Yes, and I'm getting to that.
Okay.
Yeah, so that's the reason why we need to find angle B, because that angle B is actually the one we're going to have 2 different measurements on. So did you guys get to this answer here? Sorry, the 0.9811, whatever that number is coming out to be.
Yes.
Okay, so now, like we did before, this is where you will end up doing that sine inverse to find the angle B itself. So again, can you tell me what your angle B comes out to be? Okay, so I've got 78.85. And that is, let me see, Abdul Aziz, Ozzy, Billy, Alicia, Jack. Alrighty, very good. So yeah, everybody's coming up with that answer. Perfect. Okay, and round it up to 2 decimal places. Okay, so here's what happens in this case is this is actually going to be what we would call as B1, because this is going to be one of those cases where your angle B can actually also be a difference between this angle we came up with and 180 minus the 78.85 degrees. So what happens is one angle ends up becoming an acute angle and the other one ends up becoming an obtuse angle. So this is actually your 2 cases. They arise from this fact over here because, again, if you look at the illustration that we had for this, let me get rid of this. So this is actually where, your angle B, which is going to be this angle here, can be 2 different angles. So you can see this one over here on the right-hand side is an acute angle. So that's your B1. And then this one over here becomes your obtuse angle, which is B2. So that's actually what creates us into having these 2 different cases for this type of an example. So this is where we're going to break this down into the value of B1 being 78.85 degrees, or B2 being 101.15 degrees. So you will see in this case, our side C and angle C are going to be two different measurements depending on, which angle B value you are using. So then can you tell me for the B1, what will we need to do to find side C and angle C? Let's start with angle C in this case. We already know angle A. We know angle B1. So what do you think angle C1 is going to come out to be? And you can do that same calculation here for C2. So give me the value for C1 first, and then the value for C2. And again, we're keeping the 2 decimal rounding for all of these values. And again, for those 4 minutes, if you're writing this out, 180 minus 25 degrees, 4 minutes, minus 78.85. If you're typing this in your calculator, you can do 180 minus, and then I would just put that in parentheses, 25 plus 4 over 60, and then minus the 78.85. So you don't have to worry about those repeating decimals. And this is all in degrees. So do you guys have an answer?
Mr. Oak, I'm confused.
Go ahead. What's up?
So on my thing, it says for like case 1, it should be the smaller value, and for case 2, it should be the larger. And when I'm doing like how you're doing your equations right here, case 1 is the larger value and case 2 is the smaller value.
Yeah, so that's okay. Just switch your numbers, but the numbers will not change. Just put them in the different boxes.
Okay, thank you.
Yeah, that's okay. Yeah, because case 1, case 2, it's not always necessary that it has to be small or large. I think that's just how your homework is doing, but that's okay. All right, so if you do this calculation over here, guys, for the case 1 that I did in my example, your angle will come out to be 76.08 degrees. It's 0.8333 repeating, but when we round it to 2 decimal places, it just comes out to be 76.08. And then for the other side with the larger angle, you end up getting, yeah, that's what I came up with, Hero, as well. So this guy comes out to be the 53.78. Because think about this, if you have an obtuse angle like 101.15 for angle B, angle C is going to be smaller. Whereas in case 1, since you had 78.85 degrees for angle B, that means we had more room for the angle C to come out to be a bigger angle. So this guy comes out to be a larger value in case 1, but it comes out to be a smaller value in case 2. Now for the last part where you're trying to find side C, you can do again side C over sine of C equals, I guess we can do with side B over sine of B, but this will become, B1, C1, and this will be small letter C1. And then on this side, it will just be C2 sine of C2 equals B over sine of B2. So when you go through these calculations, your C1 will come out to be, let's see, what was our B? 22. So this guy will come out to be 22 over sine of 78.85 degrees. And then you're multiplying this with sine of 76.08 degrees. On this side, you will have C2 equal same thing, 22 over sine of, but this time our angle was 101.15 for angle B. And then angle C was 53.78 degrees. And then when you put this through your calculator, we should come up with, let me see, what did I have for this guy? So he comes out to be approximately 21.76. And this guy is coming out to be approximately 18.09. And you should be able to verify those calculations, just by looking at those.
Where did you get the 78.85 from?
That's what we had for angle B1 in that first case.
And then the other one?
That was the C1 value, the 76.08.
Oh, okay, that makes sense.
Okay, good. So just rounding it again to 2 decimal places. Like I said, you should be able to verify your angle measurements here. So anybody who did not come up with these numbers, and if you had a question on that. Okay, so this is how, you come up with those 2 different scenarios over here. So you will end up with 2 different angle values for angle B and 2 different values for angle C and side C because of those 2 cases. Your original A, B, and C, that was given to you will obviously stay the same. It's only going to be the new ones that you're trying to find, which will end up giving you those 2 different answers. And then as Eusebia was mentioning, looks like your homework is kind of being particular about where you put those answers and in which boxes. So just be kind of mindful of that as you go through your examples. All right, guys, so you have seen the 2 cases that we have with the law of sines, where you're given 2 angles and a side, or if you're given 2 sides and an angle, and then how those kind of break down. Then we will look at what if you're given all 3 sides and you're asked to find the angles, or if you are given, what was our last case over here? If you are given, I think, 2 sides and an angle in between, how you solve that. So those actually happen with law of cosines, which is what we will be looking at in section 3.2. So work through your homework. Let me know if you have any questions. And then if you are interested in retaking any of the first 3 exams, let me know, or if you want to wait till the last exam and then decide which one you want to take. Just kind of let me know what you would like to do. All right, guys. So this is where we're stopping for today. If you have any questions, I have office hours from 1 to 2, or if you want to stay back. So be careful, everyone. I'll see you on Wednesday. Be careful. Stay safe, guys. Bye-bye. Take care.